Hi there, math lovers. Welcome to this first video of the channel Solutions from the Book. First of all, I would like to say a few words about my channel, which has recently opened. This channel is dedicated to the timeless and elegant mathematical proofs and solutions of Olympiad problems up to high school given around the world. But not only this, because we will be posting also brain teasers, riddles of mathematical concepts for different problems. This channel and the name of this channel was inspired by the idea of the famous mathematician Paul Erdős of the book, which was a mythical collection of the most beautiful and elegant proofs in mathematics. I really hope that you will like the video, and please, if you like and find this video useful, don't forget to like, comment and subscribe to stay up to date with the new videos that this channel will post. So, without further ado, let's dive into the problem. This problem was given in IMO 2009, which is the most prestigious Olympiad around the world for high school students. This was given in the IMO 2009, which was held in Germany. As many of you might know, IMO consists of 6 questions, which are given over 2 days, with a time of 4.5 hours a day for 3 problems. Generally, problem number 1 and number 4 are the most easy problem and the most accessible ones. Problems number 2 and number 5 are a little bit more difficult, but are also, let's say, accessible. And the most difficult problems are problem number 3 and number 6 of each day. And we start with IMO 2009 question 1. I wanted to say that first of all, of course there are a lot of solutions to these problems around the web. You can find them in different mathematical pages, and the reason why am I doing this video is because I think I will present a very elementary solution to this problem, which does not require knowledge of mathematical tricks or knowledge about congruencies, modulos, etc. So this, in my opinion, is a very straightforward and very elementary solution to this problem, which is quite rare given, let's say, the high level of mathematics which is presented in IMO. So without further ado, let's dive into the problem. The problem states, let n be a positive integer and let a1, a2 up to ak with k greater or equal to 2 be distinct integers in the set 1, 2 up to n, such that n divides a1, which multiplies I plus 1 minus 1 for a from 1 to k minus 1. Prove that n does not divide ak times a1 minus 1. I have covered the solution of this problem only to go through this solution step by step along with you, so we can all understand the thought process which goes into this solution. So first of all, we start with some simple observations about the problem. We are given that for I from 1, 2 up to k minus 1, we notice that n divides a1 times a2 minus 1, n divides a2 times a3 minus 1, and so on up to n divides ak minus 1 times ak minus 1. So, given these divisions, we can make this simple statement. Given that n divides a1 times a2 minus 1, this means that there exists a number from the set of natural numbers x1 such that a1 times a2 minus 1 is equal to x1 times n. Now we do one of the important parts of this solution. We will multiply both sides of this expression with a3 minus 1, and we will get a1 times a2 times a3 minus 1 is equal to x1 times n times a3 minus 1 plus a1 times a3 minus 1 as in this expression. But we make now some simple statements. We know that the left side, we have one term on the left side and two terms on the right side. The left side term a1 times a2 times a3 minus 1 divides n, because from the condition of the problem, n divides a2 times a3 minus 1, which is a part of this expression. So this, let's say this, the right, sorry, the left term side divides n. On the right side, we have that the first expression, x1 times n times a3 minus 1, indeed divides n, because n is a factor of this multiplication. And given this reasoning, so in three terms, two of them divides n, we will have that also the third term, which in this case is a1 times a3 minus 1, will divide n, because n divides, let's say, if we take this expression on the left hand side, n divides both these terms, so the division on the left side will be a natural number. This means that also the division of a1 times a3 minus 1 divided by n will be a natural number. So n divides a1 times a3 minus 1. This is a very important result which we have for the solution of this problem, because we now will continue with our reasoning. In the same manner, we will expand this knowledge that we just got of this problem by proving now that a1 does not only divide a1 times a3 minus 1, but it also divides a1 times a4 minus 1. So to prove that, we start from the expression n divides a1 times a3 minus 1, which we just proved. This means that, as the same reasoning we did above, there exists a natural number x2 which belongs to n, such that a1 times a3 minus 1 is equal to x2 times n. We multiply in this case both sides with ak minus 1, a4 minus 1, and we do the same reasoning that we just did for the expression above. So left hand side is divisible by n. One of the terms of the right side is divisible by n, so also this third term will be divisible by n. So we just proved that n also divides a1 times a4 minus 1. So with this knowledge, we might deduct in a similar fashion. We continue to prove that n divides a1 times a5 minus 1, n divides a1 times a6 minus 1, and so on, up to the expression that n divides a1 times ak minus 1. We will use this very important fact to prove by contradiction that indeed, from the request of these problems, the expression ak times a1 minus 1 does not divide n. So, with this acquired information, we go to the next step of our reasoning for this problem. We return to the original question that we are asked to prove that n does not divide ak times a1 minus 1. We will try to rearrange this expression so it suits better our contradiction proof. So we can express ak times a1 minus 1 is equal, by expanding a1 times ak minus ak, it is equal by a1 times ak minus 1 minus ak minus a1. Let's suppose for the moment, for the sake of contradiction, that indeed n divides ak times a1 minus 1. This would mean that in this equation number 1 over here, if we divide both sides by n, we would have that ak times a1 minus 1 divided by n is equal to a1 times ak minus 1 divided by n plus ak minus a1 divided by n. Now, we do a simple reasoning. The left side of this expression is a natural number, because based on our supposition, we said that ak times a1 minus 1, we suppose that it divides n. On the right side, however, the first term indeed divides n, because we proved that n divides a1 times ak minus 1, which was a very important result we got up here. So this means that in this expression, from these three terms, two of them divides n. So we have left side term divides n, and one of the right side terms divides n. This means that the difference of these two numbers will be a multiple of n. But this also means that the expression ak minus a1 divided by n will be also natural number, but this is impossible because of the simple reasoning that the set of numbers a1, a2 up to ak is taken from the set of numbers 1, 2 up to n. Well, this will mean that the difference ak minus a1 will be smaller than n, because the maximal value of ak can be n, and the minimum value, so we maximize the difference, the minimal value of a1 will be 1, and it will give n minus 1. But still, n minus 1 is smaller than n, and it does not divide n. So we reached a contradiction. So this means, by reaching a contradiction, this means that our original supposition that indeed ak times a1 minus 1 is divisible by n is not true. So this means that we finally were able to prove the request of this problem that n does not divide ak times a1 minus 1. So I will leave the solution for a little bit on your screen, so you can pause the video maybe and have a better look on this solution. As I have described in the title of this video, this is a very elementary solution which does not require any special knowledge of mathematics, and which is quite rare on problems in such prestigious mathematical Olympiads. And I really hope that you like this solution, and please, if you liked it, please don't forget to like, comment and subscribe to stay up to date with the new videos that our channel will upload. Up to then, thank you very much for having a look and giving a chance to the channel. See you on the next videos. Bye.